Are we alone in the universe? The answer may lie in our ability to protect other worlds from contamination. Join me on a journey to uncover the crucial role of planetary protection in preserving the integrity of our solar system. From Mars to Europa, the fate of potential extraterrestrial life rests on our actions. Don't miss out on this eye-opening video and learn how you can contribute to the quest for answers. Click now to watch and be part of the solution. What is planetary protection? Planetary protection is a guiding principle in the design of an interplanetary mission, aiming to prevent biological contamination of both the target celestial body and the Earth in the case of sample return missions. Planetary protection reflects both the unknown nature of the space environment and the desire of the scientific community to preserve the pristine nature of celestial bodies until they can be studied in detail. There are two types of interplanetary contamination. Forward contamination is the transfer of viable organisms from Earth to another celestial body. Back contamination is the transfer of extraterrestrial organisms, if they exist, back to the Earth's biosphere. Planetary protection. Preventing contamination of other worlds. Forward contamination is prevented by sterilizing space probes sent to sensitive areas of the solar system. Missions are classified depending on whether their destinations are of interest for the search for life, and whether there is any chance that Earth life could reproduce there. NASA made these policies official with the issuing of Management Manual NMI 4-41, NASA Unmanned Spacecraft Decontamination Policy, on September 9, 1963. Before NMI 4-41, the same sterilization requirements were required on all outgoing spacecraft, regardless of their target. Difficulties in the sterilization of Ranger probes sent to the Moon are the primary reasons for NASA's change to a target-by-target basis in assessing the likelihood of forward contamination. Some destinations, such as Mercury, need no precautions at all. Others, such as the Moon, require documentation but nothing more, while destinations such as Mars require sterilization of the rovers sent there. Back contamination would be prevented by containment or quarantine. However, there have been no sample returns thought to have any possibility of a back contamination risk since the Apollo missions. The Apollo regulations have been rescinded and new regulations have yet to be developed. NASA's big plans. After years of debate, NASA plans to update its guidelines for how much biological contamination of other worlds will be allowed while the agency explores the solar system. The new rules would relax some of the agency's requirements for how to explore the Moon and Mars, two high-profile destinations where NASA hopes to send astronauts in the coming years. For decades, NASA has followed fairly strict rules about how much biological contamination is considered acceptable whenever the agency sends probes, or people, to other planets. It's a concept known as planetary protection, and it has a legal basis in a treaty signed more than 50 years ago. Called the Outer Space Treaty, it challenges nations to explore other worlds, to avoid their harmful contamination, and to not bring back any alien microbes from other worlds that could cause harm to Earth. A big goal of planetary protection has been to keep us from tracking microbes all over the solar system. That way, if we were to come across some kind of life form in another world, we would know with certainty that it actually came from that world, and that we didn't put it there on accident. Planetary protection is also focused on keeping humans safe too. If a country does find life, we want to make sure it's not going to wipe us out if they bring it back to our planet. Adhering to planetary protection has always been a bit of a trade-off, since practically everything we send into space has some kind of microbe on it. Depending on where they're headed in the solar system, spacecraft often undergo really strict cleaning procedures in an attempt to get rid of these tiny organisms. For some, that means getting baked at high temperatures to kill off microbes and to make the vehicles as immaculate as possible. But now, NASA is particularly focused on sending humans into deep space once again. And whenever people go into space, they carry tons of bacteria with them, no matter how much we clean. With human exploration such a high priority, NASA now wants to rethink some of the stricter requirements for the Moon and Mars. Otherwise, human exploration would be too tough to pull off. Today, NASA released 2 new interim directives that lay out potential changes to the guidelines for exploring the Moon and Mars. It follows years of urging from the space community to update these rules. How do we prevent the contamination of other worlds? Preventing contamination of other worlds is a crucial aspect of space exploration, as it is essential to protect other planets and their potential for extraterrestrial life from Earth's microbes and other contaminants. Several steps can be taken to prevent contamination, including following strict sterilization protocols for spacecraft and equipment that will come into contact with other planets, moons, or asteroids. This involves removing any traces of biological material from these objects, such as bacteria, viruses, or fungi, through methods such as heat treatment, irradiation, or chemical disinfection. Additionally, spacecraft and their payloads are subject to rigorous cleaning and testing procedures to ensure that they are free of contaminants. This includes keeping the spacecraft and equipment in clean rooms, where the air is filtered and sterilized to reduce the number of airborne particles. Scientists and engineers also take precautions to minimize the number of people who come into contact with the spacecraft and its components, as humans are a significant source of microbial contamination. Another critical aspect of preventing contamination is identifying and studying potential landing sites for spacecraft. This includes selecting areas that are unlikely to contain biological material, such as deserts or icy polar regions. Scientists also look for signs of past or present life on these planets or moons, as it may be necessary to avoid these areas to prevent contamination. Overall, preventing contamination of other worlds is a complex and challenging task, but it is essential to protect the potential for extraterrestrial life and ensure that our exploration of the universe does not inadvertently harm other planets or moons. It requires a multidisciplinary approach involving scientists, engineers, and policymakers to establish and enforce strict protocols and procedures for space exploration. In conclusion, the concept of planetary protection is crucial to ensure the preservation of our universe and the discovery of extraterrestrial life. The steps taken by space agencies and scientists to prevent contamination of other worlds are vital to maintaining the pristine environment of these celestial bodies. So, let's spread awareness about the significance of planetary protection and work towards preserving the integrity of our universe. Join the cause today and take a step towards protecting the future of space exploration. Don't forget to subscribe to our channel, or you will miss out on our